Good morning, students. Today we are going to discuss about imperfections in solids. As all of us we know that at absolute zero, crystal stands to have a perfectly ordered arrangement in a three-dimensional periodic arrangement. This arrangement is of atoms or ions or molecules. Fine, beta. So it look like this type of structure in it. So ideally, if we can say that there should be a perfect order in this arrangement. But as the temperature increases, the crystal start deviating from the perfectly ordered arrangement. So it means the crystals in nature are not perfect. They do not possess perfectly ordered arrangement. Okay, so any deviation from the perfectly ordered arrangement constitutes a defect or imperfection. These defects are also called thermodynamic defects. These defects arises sometimes due to impurities or dislocation, and any deviation from the perfectly ordered arrangement of atoms or ions or molecules in the crystal is called imperfection or defects. Fine. So as I have already discussed with you that these defects are also known as thermodynamic defects because the number of these defects depend on the temperature. So from this we can say that defects are further categorized into two types, that is point defect and line defects. Now as you can see here that point defects can be defined, or these are the irregularities or deviations from ideal arrangement around a point or an atom in a crystal. As you can see that the irregularity is arises. ठीक है बच्चे, जैसा कि आप देख रहे हैं एक बीच में एक एटम और आपका आ गया. So such defects are known as point defect, whereas line defects are the irregularities or deviations from ideal arrangement in entire row of lattice point, as it is shown in the figure, that the ideal arrangement is like this, or where in this arrangement if there is an entire row is displaced, then such a displaced or not regular, then we can say that such defects are known as the line defects. Okay, so if we see here that the point defects are further that categorized into the stochiometric defects, non-stochiometric defects and impurity defects, okay, which we are going to discuss now. Now if we are talking about the stochiometric defects, so if imperfection in the crystal are such that the ratio between the cations and anions remain same as it is represented by the molecular formula of the compound, then such a defect is known as stochiometric defect. Means simple, which we can say that the defects which do not disturb the stochiometry, that means the ratio of number of positive and negative ions. So such defects are also known as thermodynamic defects or intrinsic defects. ऑल राइट बेटा, सो हमने क्या बात करी कि ऐसा डिफेक्ट जो कि रेशो ऑफ नंबर को आगे डिस्टर्ब नहीं कर रहा, उसे हम क्या कहते हैं? थर्मोडायनेमिक डिफेक्ट, इंट्रिंसिक डिफेक्ट और स्टोशियोमेट्रिक डिफेक्ट. Stochiometric defect is further categorized into two types, that is vacancy defect and interstitial defect. Now we are going to discuss about the vacancy defect. As you can see here that when in a crystal some lattice site or is vacant, okay, then the crystal is said to have a vacancy defect. This type of defect is usually occur due to absorption of heat from the surroundings, and which results further decrease in the density of substance. So इस defect का क्या characteristic है? That there is the decrease in the density of substance noted down or observed. Whereas in the another one type of interstitial defect, it arises due to the presence of constituent particle, or we can say the atoms, molecules or ions. In this case, when more atoms or molecules that comes in the vacant area or in the interstitial sites occupy the position, then such defects are known as the interstitial defects, and in which the interstitial sites occur. So the particles present in these vacancies are known as interstitials. As the number of particles within the crystal increases, so we can say the density of a substance that also increases. Okay beta, so the constituent particles occupying the interstitial sites are called interstitials, and in interstitial or vacancy defects, we can say these are generally shown by the non-ionic solids, means atoms, ions or molecules, whereas ionic solids do not show these simple vacancy defects. Whereas interstitial defects, instead of this, they are showing Schottky and Frankl defects. Okay, so these interstitial defects, that is further what they are showing? They are showing Schottky and Frankl defect, which is shown by usually the ionic solids. Okay, so as you can see here, the example at it is given. Schottky defect. This type of defect is created when one positive ion and one negative ion are missing from their respective positions, leaving behind a pair of holes. क्या छोड़ रहा है बेटा? Pair of holes. So such defect is simply a vacancy defect. As you can see here that in this type of defect, electrical neutrality is maintained because one positive or one negative or two pairs of positive and two pairs of negative is missing, and so far you can say that mass also that goes decreasing while volume remain the same. Fine. Presence of a large number Schottky defect site lowers the density of solid. Obviously जितना ज़्यादा होता जाएगा वो क्या करेगा? Density को decrease कर देगा. So the type of compounds which usually shown are Schottky defects, or we can say that is usually common in high ionic compounds, मतलब which have high coordination number and small difference in between the cations and anion sizes, or we can say where the size of positive and negative ions are almost equal. So such type of a compounds shows Schottky defects. For example, the ionic compounds which exhibit Schottky defect, these are sodium chloride, potassium chloride, cesium chloride, KBr, potassium bromide, silver bromide, etc. So we can say that is Schottky defect in crystal result in significant decrease in its density. There is also like a NaCl uh, is having one defect in 10 raised to the 5 lattices, and the main characteristics of Schottky defect that it maintain the electrical neutrality of the crystal. For example, in case of sodium chloride, so there are about 10 raised to the power 22 ions in 1 cubic centimeter of sodium chloride, and there are approximately 10 raised to the power 6 Schottky pairs per cubic centimeter at room temperature. Therefore, we can say sodium chloride at room temperature, there is 1 Schottky defect per 10 raised to the power 16 ions. Okay, so number of defects increases to 1 in 10 raised to the power 6 sites, we can say, at 775 Kelvin, and 1 in 10 raised to the power 4 sites at 1075 Kelvin. So जैसा अभी बात करी हमने, that is all about Schottky defect. Now we discuss about the Frankl defects. Now beta, Frankl defect is usually created when an ion leaves its correct lattice site and occupy an interstitial site. As you can see here, एक पॉजिटिव चार्ज उठा और कहाँ चला गया? इंटरस्टिशियल साइट, एम्प्टी स्पेस पे जाकर के अपने को पोजीशन ऑक्यूपाई कर ली. सो फ्रैंकल डिफेक्ट इज usually a combination of vacancy defect at its original site and interstitial defect at its new location. ठीक है? So it is also we can say that it gives us a dislocation defect क्योंकि site change हो रही है, और it maintain the electrical neutrality. Why? Because the number of charges remain the same, as well as the stoichiometry of the compound that is also maintained in this one defect. Why? Because in this case the formula of the compound that will not change. So this defect is a combination of vacancy defect and interstitial defect. It is a vacancy defect at its original site, as you can see here that यहाँ पर vacancy create हुई तो यहाँ पे कौन सा defect आ गया? Vacancy defect. और जहाँ पर charge जा करके new position पे आया, that is interstitial site. So it is a interstitial defect. It's at its new location. Since no ions are missing from the crystal as a whole, as I have already told you, so Frankl defect do not affect the density. So please keep it in your mind that Frankl defect do not affect the density. Frankl defect are also common in ionic compounds which have low coordination number and large difference in size between cations and anions. Okay, beta? So we can say that when there is a difference in size between positive and negative ions, then we can say it as a, or consider it as a Frankl defect. These defects are found in silver halides usually because of small size of silver ion, and in zinc sulfide also, that is also because of small size of zinc ion. In pure alkali halides, Frankl defects are not observed. Why beta? Because the ions are bigger than the voids, or we can say than the empty spaces. So we can say that zinc sulfide, silver chloride, silver bromide, silver iodide are example of Frankl defects. Next one is about the impurity defects. Okay, so the in impurity defects, if we talk about, so with the defects in the ionic solids that can also be introduced by adding any impurity. Like you can see here that a green color positive charge is present in it. So the defects which may be introduced by adding any impurity ion, that is known as impurity defect. If impurity ions are in a different valence state from that of the host ions जो already थी उनके comparatively, so such cases vacancies are created. For example, if we are talking about, you can see here that a red color positive charge is shown here, so maybe positive charge of one positive or two positive, so that is created. But along with that, like an example of sodium chloride, Na is having up one positive charge on it, whereas one impure positive charge ion of strontium Sr2 positive is also added in its site. ठीक है, एक आयन आ गया, that is Sr2 positive. So in this one case, all of the Na positive and Cl negative are relocated according to the arrangement, and when in this one case addition of strontium chloride to sodium chloride yields solid solution where each Sr2 positive ion replaces two Na positive ions. दो रिप्लेस हो गए क्योंकि दो की साइड चाहिए थी, एंड देयरफॉर Sr2 positive ions removed, sorry, Na2 positive, Na positive, two Na positive ions are removed, whereas Sr2 positive ion is located and one cationic vacancy is created. All right, so in the similar type of defect and behavior that can be observed in cadmium chloride when it is added to the silver chloride. So cadmium is also having a Cd2 positive charge.